BTEC Applied Science for AAQ, another chemistry video, another D1.1 because it's a big chunk. So I've actually done, I think it's about 3 videos on this. This one is about solutions. Now in this video, we're going to be calculating the concentration of different solutions and also other things like calculating the amount of stuff in the solution, how many moles in the solution or how many grams in the solution. And we're going to do quite a bit of practice because in Unit 4, if you're doing extended certificate in Unit 4, you're going to be doing like a titration and you're going to need to be able to do this. Okay, we're going to practice doing the kind of calculations that you will do when you do your titration, from the results of your titration, and hopefully we will find the solutions to those calculations. Moving swiftly on, look at this. The molar mass of copper sulfate is 159.6 grams. So 1 mole of copper sulfate, 159.6 grams. Anhydrous means the crystals haven't got any water in them. If you've got some copper sulfate and it's blue, that means that the crystals have got some water, actually in the crystals. And I don't want that there. So what I need to do is get my copper sulfate and put it in an oven, and that will get rid of the water and the crystals will actually become white. And that's when it's anhydrous. Having water in it is going to affect my calculations. I just want copper sulfate, the good stuff. I don't want any water in my crystals. Okay, so anhydrous copper sulfate. And what I'm going to do is I'm going to get 1/10 of a mole, which is 15.96. And I'm going to dissolve that in 1 decimeter cubed of water, which you'll remember is 1 liter of water. And that's going to give me a solution which is 0.1 molar solution. And that means it's 0.1 moles per decimeter cubed. That is the concentration of my solution. 0.1 capital M, 0.1 molar is 0.1 moles per decimeter cubed. It would be worth remembering this little triangle. Yes, so the concentration is the number of moles divided by the volume. Remember that the volume has to be in decimeter cubed. You can also measure concentration in grams per decimeter cubed, but if you do that, it's not molarity anymore. You can't call that molarity. You can only just call that concentration. So be careful with the units. We'll be using moles per decimeter cubed in this video from now on, and I suggest you do as well. Right then, guess what you have to do on this slide? Go for it, pen, paper, don't be lazy, and I'll show you the answer in 3, 2, 1. There you go. Nice bit of practice there. Okay, as I said earlier, if we measure the concentration in moles per decimeter cubed, we can refer to it as molarity. So 0.25 moles per decimeter cubed is 0.25 molar, capital M. Now, titration. What's titration? If you haven't done one yet, maybe you did some at GCSE. So basically, it's used to find the concentration of something like an acid. If we want to find the concentration of an acid, then what we do is we can neutralize it with something that we know the concentration of, like an alkali. And then if we know the amount of alkali, we can work out the number of moles of that. And then we know the number of moles in the acid. And then if we know the volume, we can work out the concentration of the acid. Okay, so basically what you do is you get a known amount of acid. You measure it very carefully with a pipette, not a teat pipette, but a proper calibrated pipette. So you measure out some of the acid and you put it in like a container, like a conical flask, and then you find out the amount of alkali you need to neutralize it in the titration. And the alkali may well go into the burette, which is this thing which has a tap at the bottom, and you can get it so that it goes like a drop at a time. And then you can use a pH meter or an indicator to find out when the neutralization has happened. So that's titration. You will be doing titrations on this course if you're doing the extended certificate. Okay, if you're just doing the certificate, then you just do units 1, 2 and 3. So sadly you don't do it. Anyway, there you go. Here's an easy calculation for you to do, and then we're going to do a smelly hard one after. Okay, so easy one. A student has a bottle of 0.5 molar sodium hydroxide, and they put 50 mils of that into a beaker. So how many moles of sodium hydroxide is in the beaker? You should work your way through these. The answer is in 3, 2, 1. There you go. So N equals CV. So that's 0.025 moles. You're given a bottle of hydrochloric acid and you don't know the molarity of the acid, the concentration of the acid. But what you do is you find that their 50 mils of sodium hydroxide can neutralize 100 mils of the acid. Okay, so how many moles of hydrochloric acid, HCl, react with the NaOH in the beaker? Looking at the equation, the stoichiometric ratio is 1 to 1, isn't it? So the ratio is 1 to 1, so that's 0.025 moles. Okay, what is the molarity of the hydrochloric acid? There you go. It's C is N over V, so 0.025 over 0.1, because it's 100 mils, 0.25 molar. Hopefully you followed that. That's the easy example. Here's the smelly one now. Okay, this is a more complicated one. This is very, very similar to what you're going to have to do in your assignment. Okay, so pay attention, make sure you can do it, follow it carefully. A student wishes to prepare a 0.1 molar solution of sodium carbonate. What mass of solid anhydrous sodium carbonate should they dissolve in 100 mils of water to do this? Do it yourself on paper. Show the answer in 3, 2, 1. There you go. So N equals CV. So 0.1 times 0.1 is 0.01 moles. Now, the molar mass of sodium carbonate should work out as 106. So 0.01 moles is 1.06 grams. Next, they find that 32 mils of their sodium carbonate solution is needed to neutralize 32 mils of some hydrochloric acid they are given. They're given a bottle of hydrochloric acid and they don't know its concentration, its molarity. But they find that 32 mils of their sodium carbonate solution neutralizes 32 mils of this hydrochloric acid in a titration. And there's the equation there. So what is the concentration of the hydrochloric acid? Do it yourself. I'll show you the answer in 3, 2, 1. So I've worked out the number of moles in my 32 mils of sodium carbonate, and it's 0.0032 moles. From the equation, we see that 2 moles of hydrochloric acid goes with 1 mole of sodium carbonate. So the stoichiometric ratio, if you like, is 2 to 1. 2 moles of hydrochloric acid, 1 mole of sodium carbonate. So how many moles of HCl Well, it's 0.0064 because it's double. It's 2 times 0.0032. And then if we divide that by the volume in decimeters cubed for 32 mils, we get 0.2 molar. So my hydrochloric acid is 0.2 molar. There's more. They are now given a bottle of sodium hydroxide solution of unknown concentration. And they find that 74 milliliters of this sodium hydroxide solution is needed to neutralize 25 milliliters of the hydrochloric acid. What is the concentration of the sodium hydroxide? Have a go yourself, see if you can work it out. There you go. So the first thing I've done is I've worked out how many moles of the HCl in my 25 mils of 0.2 molar solution. From the equation, we see that the ratio is 1:1 of HCl to NaOH. And so now I can work out the concentration of the sodium hydroxide, and it's 0.068 molar. It's a big chew, but this is basically what you are going to have to do. There's different stages, there's different titrations that you're going to have to do. I suggest you study this slide and make sure you can do the sums. When you do it, it won't be friendly whole numbers either. I've got you scared now, haven't I? Yeah, good.